Good afternoon, everyone. So I hope that you had a good lunch. And now I'm not talking about maps and graphical nice stuff, but more about XML. So it's going to be a bit indigenous for you, maybe. So basically, I'm going to talk about how we are trying to strengthen R in support to managing spatial data infrastructures. So I'm going to give a quick definition of an infrastructure. They are bigger than that, but that's the simple one. So basically, you have data repositories or ideally spatial databases. They can be file systems with shape files, etc., CSV files. You have geographic data servers, and generally a metadata catalog where you are describing your data sets. So if we look at the software existing today, there are many. Some are related to standards, and generally they are not evolving a lot in time. They are quite sustainable, and others that are just software related, like related to GeoServer, GeoNetwork, web tools, for those that know these tools. And the big issue is that as of today, this is quite reserved to GIS IT specialized community, basically. So there are many data managers that are struggling a lot to produce, to use programmatic tools, basically because they don't have the programming language that they prefer. So generally speaking, data managers that deal with JS datasets try to use Java software. This is basically what I did years ago. Otherwise, they can switch to Python. But a few years ago, there was absolutely nothing in R to deal with that. So when speaking with my colleagues, they say, okay, how can I do if I need to generate 1,000 metadata descriptions for my geographic data sets? So I told him, okay, let's do an R package, and it starts like this. So basically, a good reason to be scared about JS standards and driving the spatial data infrastructure is that there is a lot of XML, like kilometers of XML, tons of XML. So I'm going to give you some example. So this is a kind of XML that you can find, and if you want to describe your data set in a catalog, you have to generate this kind of thing. So it's quite ugly. Go back. But when you are familiar with catalogs, basically this is the kind of product that you get at the end. So you can have nice products, and this allows you to discover better your data set on the web. There are other even worse XML files. Here I'm basically describing the structure of a complete time series for fisheries datasets, for global fisheries datasets. So it's like a huge XML. So basically my colleagues before were dealing with these kind of files, trying to do it even manually sometimes or using web complex forms. So the end product, of course, looks like much better, where you have your data structure definitions and you can reuse your time series safely. So the problem is that how can we deal with this kind of file? How can we read this file in R? How can we produce these files in R? So this is where, if you start wondering about that, it can be really scaring. So the idea was to create packages that can be used by any data manager that not necessarily have skills in geographic information standards. So there are a series of standard packages. I'm not going to describe everything, but I'm going to focus on the first two packages, one which is to write, read, and validate geographic information metadata into R. So basically this deals with the ISO and OGC standards. Sorry. We will also show a bit of how we can interact directly with OGC services in a standard way, and how to push some metadata on the web, how can we update metadata for these services. I'm not going to describe entirely the other packages that are software specific, which are dealing with API like GeoServer or GeoNetwork. And I will briefly introduce the GeoFlow initiative, which tends to help new guys and data manager that start from scratch and want to manage their spatial data infrastructure with R. So basically, geometa is an API on top of ISO and OGC metadata schemas. So here it's fully standard. So the problem is that since they are standard that are very exhaustive, the package is very exhaustive, and if you don't know how to deal with this kind of standard, it can be hard at the beginning. The references, so this package manages a series of standards like dataset and service metadata. Also the GML, if you are familiar with this format for GIS. Feature catalog is used for describing datasets. And of course, we have the XML implementations. There are a series of profiles, so there are specific communities that use this standard, but customize it for their own needs. So these are some examples. And until a few years ago, this capacity was only possible with robust Java software or Python. So the principle of geometa is that we use our 6 classes, so it's an object-oriented R model, and for each element in the standard, you will have 1 class. So on the right, you have the inventory of all statistics of classes that are supported. We reached the full coverage for geographic dataset metadata and imagery metadata recently with the support of the R consortium. We also have about 1/3 of the GML standard covered, which is less, but when you see the GML standard, it's quite good. So with the R consortium, so this is what we did. We added the support for producing multi-language metadata. We have added also an Inspire metadata validator for the European community. So you can produce your metadata and you can check if they are Inspire compliant directly into R. The full coverage, I already told it. And we are also experimenting a generic converter to move from one metadata standard to another. So we are focusing on the 2 metadata standards, one which is the ecological metadata language. So we are trying to move from EML to ISO-OGC and the other way around, and also to produce OGC metadata from a NetCDF CF dataset, which embed some metadata. So how it works, it's very basic. Each class inherits a generic parent class, which have generic functions. So you have the encode, which will produce the XML, the decode, which can read an XML into an object. You have a validate method that allows you to validate first according to the standard schemas and also according to the Inspire specifications, and you can save a file. So we have also a generic function that allows you to read any kind of ISO XML metadata into R, into an object that you can then manipulate easily. So this is the beginning. When you start from scratch, you want to create some metadata for your data sets. So you can create an object, ISO metadata, $new, and then you have a series of methods, plenty of methods to describe your data sets. We have also added some print methods. So basically, you can have a comprehensive view of what you're producing. So this is a very basic metadata. There is absolutely nothing. So if we check the Inspire validation, we'll get about 0% maybe. So we also manage code lists. In the standards, you have many embedded vocabularies. So the package lists this for you. So you can get the list of code lists, but you can also interrogate one code list to check which kind of value are authorized in some element. The multi-language, so all textual elements have some arguments in the functions, locals, which allows you to specify the language you want. The encode and save methods, which are the main function of interest, because this is what you produce the XML for you. So basically, you run $encode, and you will get this kind of XML. By default, we are checking the validation, the validity of your XML. So basically on the top, you will see that you will have some message about the validation. We also embed some comment in the XML to keep track of how you produce this, which version of package you are using, and the validity status. Same for Inspire. So if I specify the option Inspire equal true, I will communicate with the Inspire validation service provided by the European community. And here I get statistics about the percentage of compliance with Inspire. We also embedded the draft report of Inspire validations, noting that this is something like a sandbox. So basically, the European Commission make it disappear after some time. Converters, so the idea is that we try to have a generic converter behind, but then for the user, we use generic function as. So basically, you take an object from geometa and you try to convert it to EML, ecological metadata language. You can do the reverse thing. You can try to do the same for NetCDF CF. So this is still really experimental because we are trying to make it as generic as possible. So reading files, so it's very straightforward. You have some XML file, either local or on a catalog, and you want to read it, so you can read ISO 19139. The perspectives that we want to consolidate the converters, and hopefully we want to collaborate much more with the communities that are developing the ecological metadata language and behind the CF conventions. We also want to move one step forward and to connect easily to web control vocabularies to make easier the metadata productions and make your dataset easily discoverable on the web. And behind, we also want to extend the coverage of the GML support to foster interoperability with OGC Web Services. So next, OWS for R basically is how we can use geometa in combination with web catalogs using standard protocols and push data and manage data, metadata, using R. So this is the status. Basically, we have a CSW protocol that allows to manage metadata and the web feature service that allows to manage data. So for metadata services, you can interact very easily with some catalogs. So this is one example with the FAO catalog. You can search metadata, get metadata, still into the geometa objects. You can perform CRUD operation like insert, update, and delete. The data services, you can grab data. So at now it's limited to vector data. So you can grab data from web feature services, and you get the result into the SF model, the simple feature model. Here, our perspective is to extend the support to web coverage service, basically to manage raster data and multidimensional imagery data for Earth observations. We also plan to include the WFS transactional mode. And to finish this presentation, the geoflow initiative. So basically, we now are able to produce metadata with R. We can push data, manage everything from R, but the limitation is that the OGC standards are quite huge and quite difficult to understand for newbies and data managers that start from scratch. So the geoflow initiative is one project that aims to facilitate all of that. Okay, so we are trying to summarize all the essential metadata that you need for describing data sets and basically automate that in a tabular way. So basically you can have two tables, one to describe your data set. One row is one data set and one metadata. Then you manage contacts separately in another table. We manage several formats. And then we have like a set of actions that you can enable or disable depending on your needs. So we are focusing on general tools and specific tools. For general tools, It's like the infrastructure where you want to push your data to assign the OI, for example. So we are now covering the Zenodo European infrastructure, but we want to also set up an action for Dataverse. And specific tools, of course, for geographic information, specialized metadata like GeoNetwork and GeoServer, so this is already managed. And this is how it works, basically, to facilitate the work. We have only one command in R, which is execute workflow, and then you have one configuration flow where you define your metadata tables, you define the target tools you want to push data and metadata, and the action you want to enable or not. So this is more or less what we have in GeoFlow, and this is what we try to summarize in one command line. And these are examples. So these are examples of spatial data infrastructure that are currently managed with this approach. So we have the Fisheries and Aquaculture Department of UNFAO that use this approach. It's finished.
Thank you very much. Is there any questions? So maybe I have one. Can you say some words about computational time? I mean, when you have big file, XML, is it costly? And
to generate the XML, it's really fast. To read the XML, it was a bit more complex until recently, but it has been optimized a lot. And now to read really big XML files, it takes very few. I mean, I tried it, for example, for FAO, it's 1 second or something like that.
any questions? Okay, so thank you very much.